Imagine a math problem so complex, so impossibly difficult, that the world's fastest supercomputer would need 10 septillion years to solve it.
That is longer than the age of the universe. It is effectively impossible.
But what if I told you that in late 2024, a new chip solved that exact problem in just 5 minutes? Welcome to the era of quantum supremacy. This is Google's Willow chip, and it didn't just break a record.
It broke the fundamental laws of what we thought computers could do. And honestly, it's starting to scare the cybersecurity experts.
For decades, quantum computing was a theory. It was noise. It was science fiction.
But Willow is different. It's the first chip that actually gets better the more errors it makes. It's the first step toward the holy grail of error correction.
So, does this mean your passwords are dead? Is AI about to become a billion times smarter? Or is this just another hype cycle? Today, we're doing a deep dive into the Willow chip, the concept of Q-Day, and why the internet as you know it is about to change forever.
To understand why Willow is such a massive deal, we first need to talk about why quantum computers have sucked for the last 20 years. You see, normal computers, like the one you're watching this on, use bits. Think of a light switch. It's either on or off. Quantum computers use qubits. A qubit is like a spinning coin. While it's spinning, it's heads and tails at the same time. This is called superposition.
This lets them do a billion calculations at once. But there is a catch. Qubits are incredibly fragile.
They suffer from something called noise. Heat, vibration, even a stray Wi-Fi signal can cause the qubit to crash.
Think of it like a house of cards. In the past, the more qubits you added, the taller the house got, and the easier it was to knock over. This was the quantum blockade. For years, making the computer bigger just made it dumber, because the errors piled up faster than the answers. Enter Google Willow. This chip features 105 qubits, but it does something magical. It achieved exponential error suppression. Instead of the house of cards falling down when you add more cards, Willow actually gets stronger. It groups qubits together to police each other. If one qubit makes a mistake, the others fix it instantly.
This is the breakthrough. We have moved from theoretical physics to engineering. And that means the timeline for Q-Day just moved up.
So, we have a computer that gets smarter the more you use it. Amazing for science. But there is a massive, terrifying elephant in the room.
It's called RSA Encryption. This is the digital padlock that protects your bank account, your emails, and military secrets.
RSA works because it relies on a math trick. It takes two huge prime numbers and multiplies them together. Doing the multiplication is easy, but working backward to find the original numbers? That's impossible.
A classic supercomputer would need a billion years to crack that code. But a stable quantum computer using Shor's algorithm could snap that padlock open in seconds.
Experts call this event Q-Day, the day the internet's security drops to zero. And here is the scary part. Hackers know it's coming. It's a strategy called harvest now, decrypt later. Foreign adversaries are stealing encrypted data today, data they can't read yet, and storing it in massive servers.
They are waiting for a chip like Willow to mature. Once it does, they unlock the vault. 20 years of secrets spilled instantly.
This puts everything at risk. The Bitcoin blockchain? Vulnerable. Your medical records? Open. The nuclear launch codes? Compromised.
This sounds like a Black Mirror episode, but don't panic just yet, because while the offense is leveling up, the defense isn't sleeping.
Okay, take a breath. The engineers building these quantum monsters aren't stupid. They knew Q-Day was coming, and for the last 6 years, they've been building a shield.
It's called PQC, Post-Quantum Cryptography. and the US government has already started forcing tech giants to use it.
The secret sauce? It's called lattice-based cryptography. If RSA was a 2D maze, lattice cryptography is a 500-dimensional grid.
Imagine trying to find a specific point in a grid that has 500 directions to move in. Even a quantum computer gets lost in that math.
It turns out, quantum computers are amazing at factoring numbers, but they are surprisingly bad at solving geometry problems. And that is our safety net.
You might actually be using this tech right now without knowing it. Apple just upgraded iMessage with PQ3, a post-quantum shield. Signal and Zoom are doing it too.
We are currently in a massive race to swap out the locks on the internet before the quantum burglars arrive.
So, if the danger can be managed, why are we taking the risk? Why build the machine at all? Because the reward isn't just faster computers, it's about saving the human race. Here is the truth. Classical computers, even the massive supercomputers we have today, are actually terrible at one specific thing. They are terrible at simulating nature. Nature doesn't run on binary code. Nature runs on quantum mechanics. To understand a molecule perfectly, you need a computer that thinks like a molecule. With the Willow chip, we stop guessing. In the pharmaceutical industry, finding a new drug is currently like searching for a needle in a haystack blindfolded. Quantum computers allow us to simulate billions of chemical reactions in seconds. We could cure Alzheimer's, map the entire human brain, or design personalized cancer treatments overnight. But it's not just about health. It's about survival. Right now, making fertilizer to feed the world consumes 2% of the entire planet's energy supply. It's dirty and inefficient. A quantum computer could find a catalyst to do that same process with zero emissions. It could discover the materials for forever batteries that make electric cars cheaper than gas.
And finally, the ultimate crossover, quantum AI. Imagine an agentic AI, but running on a quantum brain.
Classical AI learns from the past. Quantum AI could simulate the future. It doesn't just read the internet. It runs experiments in a virtual universe to solve problems we haven't even thought of yet. This is why Google, IBM, and nations around the world are spending billions. We aren't just building a faster calculator. We are building a microscope for the fabric of reality. So where does that leave us? We are standing on the edge of a knife. On one side, the end of digital privacy. On the other, a new age of discovery. Google's Willow chip proved that the impossible is now just an engineering problem. The clock is ticking and the race is on. I want to know what you think. Is Q-Day a real threat to your data or just more tech hype? Let me know in the comments below. I actually read them. Don't forget to subscribe to stay ahead of the curve. I'm Neo Fines, and I'll see you in the next one.